Okay, so here we're going to give you an overview of the breakpoints in MPLAB X, and this begins with a bit of a theory lesson of what is there, different types of breakpoints. Then, in order to understand hardware breakpoints, we're going to explain what the Debug Executive is, and after that, look at the Harvard architecture microcontrollers, because that is what was being supported when the different types of breakpoints were designed. We'll then look at how the hardware breakpoints do work behind the scenes, looking at an instruction address breakpoint in program memory and contrasting that with a data breakpoint, which, as we'll see, will be in RAM. Once we understand how this works behind the scenes, we'll also be able to understand what SCID is and when to expect it. Software breakpoints work in a slightly different way, and we'll show you how MPLAB X programs break instructions and adjust the program counter to make the experience seamless. And then we'll notice that you can mix hardware and software breakpoints. So, two major types are software and hardware, and you can see that software breakpoints are just program memory breakpoints, line and address, whereas hardware have more interesting options. And we'll cover those as we go. So hardware breakpoints are implemented with comparison registers built into the target microcontroller. Upon match with the item being watched, the program halts and control is transferred to the Debug Executive, which we'll explain in a moment. Now, hardware breakpoints are limited in number, and in the project dashboard you'll see that the number of hardware breakpoints is listed, and you can see that software breakpoints are either enabled or disabled. The Debug Executive is basically a debug interrupt service routine for debugging. The processor halts either by hitting a breakpoint or halted by the user. The processor vectors to a special address that contains the Debug Executive. Registers are saved on entry and stored on exit, just like in other ISRs. The most common commands serviced are read this location in memory. This is how the variable windows get updated. The second most common command would be a run or step command. When these are issued, the Debug Executive restores saved registers and returns the user's code at the point it was halted, just like any other ISR. You can find a nice article on the Debug Executive by searching the How Do I bar, which searches Microchip developer help. Let's have a look at a Harvard architecture. So these are microcontrollers which have separate program and data memories or buses, and this facilitates concurrent instruction and data access. Now, interestingly enough, the first examples mentioned by Wikipedia are the PIC and AVR microcontrollers from Microchip technology. Both of these processors have separate program memory and data memory buses. So what's happening behind the scenes? Well, when you select an address breakpoint and enter an address, you'll see that the comparison registers are looking for that address, that program memory address on the instruction address bus. When you set a data breakpoint, the same thing is happening except on the data bus, where we're looking for a match of that address. With data breakpoints, it's also possible to look for something a little bit more specific. So besides an address, you can look for a value. So we're actually looking at the value on the data bits as well. SCID is a result of the fact that the instruction where the break occurs will always execute completely, and anything pending in the pipeline will execute as well. For single cycle instructions, this adds a one instruction SCID. For multiple cycle instructions and branches, it can be multiple cycles of SCID. In the example in this slide, the break on the first line of assembly code associated with LCD put int, but in fact the break occurs 2 instruction cycles later. Software breakpoints are implemented by replacing the instruction at the breakpoint address with a break instruction, which will halt the program and turn over control to the Debug Executive. There is a high-level control on the project dashboard to turn on and off software breakpoints, and essentially they are unlimited in number. Let's have a look at the process behind the scenes. So, if we wanted to place a breakpoint at address 274, we would click in the glyph margin here, and essentially what would happen behind the scenes is that MPLAB X would program the microcontroller, replacing whatever instruction was at this address with a reserved break instruction. Now, when you run the code, MPLAB X reaches and executes the break instruction and then halts. So the debugger stops at the breakpoint because of the break instruction. The program counter, because it's executed the break instruction, necessarily points to the next instruction. So the program counter is decremented by 1 and the original instruction is reprogrammed, so the flash is programmed again. Note that there's no skid effects with software breakpoints. The original instruction is then executed as you step over or run the program. So the program counter again points to the next instruction. As you step over that original instruction, MPLAB X again puts the break instruction back by reprogramming the microcontroller so that you can hit the breakpoint again. Then the whole process repeats itself. Software breakpoints use at least 2 reflashes on a device during one breakpoint, so a device used in extensive debugging should not be used as a final production device. Though keep in mind, the devices typically do support 100,000 programming cycles. From the debugger window, you might see running, setting software breakpoints, that this is complete, and then that the target is halted when it hits a breakpoint. Software and hardware breakpoints may be mixed freely, and in fact you might not be aware that this is happening. Software breakpoints are automatically used when you exceed available hardware breakpoints, and software breakpoints are converted into hardware breakpoints when they are added to a sequence, a tuple, or assigned to the stopwatch. So all the features which are not supported by software breakpoints.